Hello there and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into a mystery that has hovered at the edge of human curiosity for as long as we've looked up. What exists outside the universe? But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe. Only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Terminated. Now, feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey into the unknown edges of space together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. You see, the idea of the edge of the universe is a question that sounds almost like it belongs in a dream. It teases the imagination with images of a cliff where stars fall into nothing, or a cosmic fence hiding something just out of sight. Maybe you've pictured a great black wall with stars clinging to one side of it, or a glass sphere containing everything we know, with emptiness yawning silently beyond. But here's the wonderful twist. According to what we understand, there may be no edge at all. At least, not in the way we usually imagine. Space doesn't end the way a field meets a fence, and the cosmos, as far as we can tell, isn't sitting inside something else like a ball in a box. Albuquerque, the truth is far stranger and more poetic. We are living inside an expanding fabric, a space that grows not into something, but simply stretches itself. The boundary we speak of is not a physical one, but a limit of light, of time, of what we can possibly know. Beyond that? Well, that's what we're here to wonder about. Prejudice, and you're not alone in this. Philosophers, scientists and dreamers have all traced their fingers along the edge of this same question. From ancient mythologies to cutting-edge physics, we've always wanted to peek just past the furthest star, not because we expect a tidy answer, but because it's in our nature to lean toward the unknown. So tonight, we'll follow that impulse softly. We'll talk about the observable universe, what we can see, and why there's a horizon we can't cross. We'll explore theories of multiverses, invisible dimensions, and cosmic membranes. We'll learn why space doesn't have an outside in the usual sense, and why that might be the most beautiful part of all. Flooring. But we'll go slowly, gently. Let each idea unfold like a map made of stardust and questions. For now, just take a breath. We'll never name. But tonight, we'll try. Somewhere inside you, there might be a childlike version of yourself, still looking up at the stars, still wondering if space ever just stops. That quiet thought, what's beyond it all, never quite leaves us, does it? Even as we learn more, even as our knowledge expands like the universe itself, the mystery just shifts a little further out of reach. It's not a flaw in our understanding, it's part of our nature. To imagine a beyond. The question lingers is because we live in a world defined by edges. Our rooms have walls, roads have ends, oceans have shores. We expect everything to be nestled inside something else. A pebble in a box in a house on a street. And so it's natural to assume the universe must be the same, a container floating inside something larger. Perhaps a void. Perhaps another dimension. Perhaps a kind of cosmic silence. The universe begins to gently unpick our expectations. It doesn't give us a neat boundary line. Instead, it offers a concept that can feel a little like trying to hold fog in your hands. The universe is not expanding into anything. Space itself is growing. Imagine you're standing on the surface of a giant balloon, not outside it, not inside it, but on the skin. As the balloon inflates, every point moves away from every other point. There's no center, no edge, just the continuous stretching of space between things. That balloon analogy is helpful. but even it can mislead us. Because it suggests there's an inside and an outside. In truth, we don't know if space is curved like that or if it's flat and infinite. It might be shaped like a saddle or a sphere or something more abstract still. And those shapes don't require a boundary. Just like the surface of Earth feels endless as you walk it, yet loops back on itself, so too might the universe. A place where you could travel forever and eventually arrive back at your starting point without ever hitting a wall. Even more curiously, we may not be able to see the full picture, no matter how far we look. Our universe has a speed limit, the speed of light, and because the universe has existed for a finite amount of time, about 13.8 billion years, we can only observe as far as light has travelled in that time. That's called the observable universe. Beyond that, there may be more, but we simply can't see it. Not because it's hidden behind a wall, but because the light hasn't had time to reach us. This leads to a strange and beautiful situation. We're surrounded by an ever-receding horizon. The farther we look, the older the light we see. Look far enough, and you're looking into the ancient past. At the edges of the observable universe, we're seeing galaxies not as they are, but as they were, billions of years ago. And even then, some galaxies are receding so quickly due to cosmic expansion that their light may never reach us at all. Recognize so, what's beyond the edge of the observable universe? Likely more universe? Galaxies we'll never see, regions of space that will remain forever out of contact, like ships drifting into opposite directions in a fog that thickens with time. The question of the edge is, in some ways, a reflection of how we think. We want endings, containers, answers, but the cosmos doesn't always play by those rules. Sometimes, instead of a fence, we find an endless field of possibility, and in place of finality, we find motion, eternal, expanding, and silent. So the question persists not because it's foolish, but because it's deeply human. It's the soft knock of wonder, echoing from within. Take a moment now. Let your shoulders soften. Breathe in and out. You don't need to understand the entire universe tonight. You don't need to solve its mysteries or reach its edge. You're just here, gently floating in the quiet curiosity of it all. There's something deeply comforting about not having all the answers. We often imagine science as a relentless pursuit of truth, as if we're hunting down the last page of a cosmic book. But more often, science is a kind of listening, a patient, open-hearted wandering. And some of the most important discoveries began not with facts, but with someone gazing up and asking, what if? Follow that kind of question, slowly, kindly, as if it were a candle flame flickering at the edge of your awareness. What exists outside the universe? Is it nothing? Something? An illusion of perspective? A doorway? A wall? Perhaps the more interesting question is, why do we ask it at all? Why does this question feel different than others? Why does it stay with us, like a tune you can't quite place? Proficiency of the answer lies in the way we experience our place in the world. You, right now, are surrounded by edges. Your skin, your room, your town, even time feels like it moves from one side to another. Sunrise to sunset, youth to age. And when we look up at the stars, we can't help but project that same framework outward. Where does this thing end? What's after that? Then what? The universe isn't made to mirror our metaphors. In fact, much of what we've learned about cosmology has required us to stretch our minds beyond what's intuitive. Space that curves, time that slows, matter that bends the path of light, a beginning that wasn't in anything, because space itself began, and time began with it. We'll talk about all of that, about space as a fabric, about universes possibly stacked or bubbling beside our own. We'll drift past the horizon of what we can observe and sail softly into speculation. But even as we do, we'll return again and again to that place of peace, that it's okay not to know, that sometimes the edge of understanding is exactly where the wonder begins. Line back if the universe were a great library, we would be curled in one of its quiet corners, reading by starlight. Not rushing, not skipping ahead, just turning one page at a time, letting each paragraph stretch into stillness. So, as we begin this long, gentle journey together, let your thoughts loosen. There is no race here. You don't have to remember each detail or follow every twist. Let your mind wander like a feather on wind. If you drift into sleep, that's perfectly fine. We'll be right here when you wake. Because the story of the edge of the universe is not just about space or time. It's about what it means to wonder, to imagine, and to rest in the presence of something far bigger than ourselves. So breathe, let go, and let's begin. Imagine standing on a quiet hillside at night, away from city lights, the sky above you scattered with stars. It might feel like you're looking out at everything, the whole universe stretching endlessly in every direction. But what you're really seeing is just a very small part of it. What we call the observable universe is, quite simply, the part of the cosmos we can see. Not because telescopes haven't been built big enough, not because something is blocking the view, but because of time and the patient, quiet speed of light. You see, light doesn't arrive instantly. It travels slowly and steadily, even when it's moving faster than anything else can. When you look at the moon, you're seeing it as it was a little over a second ago, the sun 8 minutes into the past, and those distant galaxies, they're messengers from billions of years ago, their light only now arriving, like long-lost postcards finally delivered. Because the universe is about 13.8 billion years old, and because light has a speed limit, there's only so far we can see. That farthest edge, the most distant light that has had time to reach us, is what defines our observable universe. And while that might sound like 13.8 billion light years in every direction, cosmic expansion has stretched space so much that the true radius of this sphere is closer to 46.5 billion light years. That's a staggering number. A round trip across this observable cosmos would span 93 billion light years. And yet beyond that luminous shell, more stars, more galaxies may continue. But we cannot know them. Their light simply hasn't arrived yet, and perhaps it never will. This doesn't mean they don't exist. In fact, the very shape and temperature of the universe suggests there's far more beyond our line of sight. But from our little perch in space and time, we are bound by what light has whispered to us. Playoffs, it's like being in a vast, foggy plain, where only the nearest hills are visible. You don't know how wide the land stretches, but the fact that it fades beyond view doesn't mean it ends. It simply disappears into distance. Loons have spent generations turning that fog into clarity, building instruments to catch the faintest signals, the weakest glimmers of galaxies too far, too red-shifted, too ancient. The Hubble Space Telescope and now the James Webb have peered deep into this quiet distance. Each photon they capture a note in the story of what came before. Prosecute for all this effort, we've only seen about 2 trillion galaxies. The ones within reach, the ones that sent their light early enough to meet our gaze. It's easy to think of the observable universe as a bubble, with us at the centre, but that's a trick of perspective. Every observer on any planet, in any galaxy, is at the centre of their own observable universe. The boundaries are not physical walls, but mathematical horizons. Wherever you are, you see your own 46.5 billion light years, in all directions. So tonight, as you lie back and drift into the dark, you are wrapped in an ancient cocoon of starlight, a gentle sphere of time-bound sight. Beyond it lies mystery, more of the same, or perhaps something stranger. But here in this moment, you are at the centre of all that you can possibly see, and that, in itself, is beautiful. Let's imagine something together. Picture yourself floating, weightless in the vast quiet of space. There's no up or down, just you, slowly turning in place, surrounded by stars. And far in the distance, all around you, is a kind of invisible shell, a horizon. You can't touch it, you can't see it, but it's there, a limit. Not of space, but of time. This is the cosmic horizons. Not because there's a wall out there, but because light, for all its incredible speed, has only had so long to travel. The universe has been expanding for about 13.8 billion years. That's how long light has been stretching out in every direction. But as strange as it may seem, the furthest galaxies we can observe are not just 13.8 billion light years away. Due to the constant expansion of space itself, many of those galaxies have moved much further since their light first set out. And so, the edge of what we can observe is now about 46.5 billion light years from us in every direction. That's our horizon. Not because the universe ends there, but because that's where the story of light, at least the part we can read, trails off into silence. Abolish of it like listening to a distant thunderstorm. The sound reaches you long after the lightning strikes. And if the storm moves further away, faster than the sound can travel, there's a point where you simply stop hearing it. It's still out there, but its message can no longer reach you. Seizing this horizon is the same. It's not the edge of existence, it's the limit of contact. What lies beyond it? Possibly more of the same: galaxies, stars, planets, maybe even civilizations too far for light to ever bridge the gap. Or perhaps stranger things, realities that no longer follow the same physical rules. But whatever is there, it remains hidden, not by darkness, but by time. Disjoints. Something humbling. This horizon is not fixed. It's always shifting. As time moves forward, more light has time to reach us. The boundary of what we can see grows slowly outward, like ink soaking into paper. But at the same time, some distant galaxies are being pushed away faster than light can travel, not because they're moving through space, but because space itself is expanding between us. These galaxies are slipping past a different kind of horizon, the event horizon of the expanding universe. One day, their light will never reach us, no matter how long we wait. It's a quiet paradox. The more we look, the more we see. But some things will always recede just beyond knowing. Izan isn't a wall, it's a clock, a map of how far light has travelled since the beginning of time. And every star you see in the night sky is within it, close enough for its light to find you. That's something beautiful, isn't it? That every photon arriving at your eye tonight has journeyed patiently through vast distances of space and billions of years just to whisper that it exists. As you lie there, wherever you are, maybe you can imagine that horizon, not as a barrier, but as a soft shell of ancient light, a boundary woven not from glass or steel, but from time itself. And as we continue, we'll follow that light deeper into the past, closer to the beginning. Because sometimes, to understand where we are, we have to look at how far the light has come. Now let's turn our attention to the quiet motion of the cosmos, the way distant galaxies seem to drift away like lanterns on a dark river. In the early 20th century, astronomers believed the universe was mostly still, a stable collection of stars and galaxies held together by gravity, unchanging on the largest scales. But then came Edwin Hubble, a name whispered across every astronomy textbook, and with him a quiet revolution. Crimson wasn't just an observer of the stars, he was a translator of light. Using powerful telescopes, he studied the glow from distant galaxies, and what he found changed everything. Nearly every galaxy he observed appeared to be moving away from us. Their light was stretched toward the red end of the spectrum, what scientists call redshift. And the farther away a galaxy was, the faster it seemed to be receding. This wasn't just a cosmic coincidence, it was a pattern, a revelation. Position meant the universe itself was expanding. Migrated, this can be a tricky thing to picture. When we say galaxies are moving away, it's tempting to imagine them racing through empty space like comets or spaceships. But that's not quite right. They're not moving through space. Space itself is stretching, carrying the galaxies with it. It's not a motion in the universe, it's a motion of the universe. Imagine dots on the surface of a balloon. As you blow up the balloon, the dots move farther apart, not because the dots are moving, but because the surface beneath them is expanding. The galaxies are those dots, and the balloon, that's space. So spake. There's no centre to this expansion, no privileged vantage point from which it all began. Every observer in every galaxy would see the same thing, galaxies rushing away in all directions. The expansion isn't something you can see from the outside, it happens everywhere at once, embedded in the very fabric of space-time. Prohibited, and it hasn't stopped. Even now, the universe is still growing. Every second, more distance appears between clusters of galaxies, not because they're pushing away, but because the stage beneath them is stretching. And the farther apart two galaxies are, the more space there is between them to stretch, so the faster they appear to recede. This was one of the most surprising discoveries in the history of science. It told us that the universe wasn't eternal and unchanging, it had a beginning, a moment when space and time themselves came into being. what we now call the Big Bang, foreground. But don't picture an explosion. That's another easy misconception. The Big Bang wasn't a fireball exploding into space. It was the sudden expansion of space itself. There was no outside, no waiting void, just everything, every atom, every force, every law of physics suddenly unfurling. Platinum. And so when you look up at the night sky and see a galaxy shimmering faintly billions of light years away, remember, it's not just drifting off into darkness, it's being carried, gently, on the tide of the universe's growth. Like a lantern floating on a slow, invisible river. Hubble gave us that view. A universe not static but alive with movement. A cosmos not confined but constantly unfolding. And the light from those galaxies? It stretches as it travels. Wavelengths grow longer. Time dilates. The farther the light has to go, the more the universe expands while it's in transit. Which means that by the time it reaches us, it carries the fingerprint not just of the galaxy it came from, but of the cosmic journey it endured. So the next time you see an image of distant galaxies, tiny smudges of light in a sea of black, remember, you're looking at travellers, not just across space, but across time, and through a universe that won't sit still. Let's linger for a moment on one of the most helpful and gently misleading metaphors in cosmology, the balloon. You may have heard it before. Imagine the universe as the surface of a balloon. Not the inside, not the outside, just the flexible skin that stretches as a balloon inflates. Now picture tiny dots on that surface. As you blow into the balloon, the dots move farther apart. That's how galaxies behave in our universe. It's a lovely analogy, and it captures something important. Galaxies aren't flying through space like confetti. Instead, space itself is growing between them. But what makes the balloon example so powerful is also what makes it so tricky, because it suggests there's an outside, some larger space the balloon is expanding into. And that, in the real universe, isn't quite right. The surface of the balloon is a two-dimensional space, curving through 3 dimensions. You and I live in a 3-dimensional universe, with space expanding in every direction. But we can't step outside to view it from a higher dimension, the way we might observe a balloon inflating in a room. In reality, there's no air around the universe, no cosmic room, no edge we might one day bump into. The universe isn't expanding into anything, it's simply expanding. Prosecute. Now that's a tough thing to grasp. Our minds are built to imagine objects in containers. A cup holds water, a box holds toys, a room holds air. So we instinctively want the universe to be inside something, a bigger thing with walls and a ceiling. But that's not how space-time works. Instead, the universe may be all there is, a complete system, expanding because space itself is dynamic. The laws of general relativity, as laid out by Einstein, don't require a surrounding space. They describe how matter and energy shape space from within. The curvature, the motion, it's all self-contained. And here's something gentle but profound. Even if the universe is curved, like the balloon surface, it still doesn't need an edge. You can walk in one direction on the surface of Earth and never fall off. You might circle the planet 1,000 times and never find a border. The surface is finite, but unbounded. It has no edge. Just as the universe might. Roofing. There's also the possibility that the universe is flat and infinite. In that case, the balloon analogy starts to falter. Imagine not a balloon, but a grid, endless in all directions, stretching forever. That too is a model scientists consider. And again, no edge, just distance without limit. So why use the balloon at all? Because it offers a way to step outside our everyday thinking. It reminds us that expansion isn't a violent pushing outward. It's a soft, continuous stretching. It tells us that every point sees the same thing, everything else drifting away. And it helps us let go, gently, of the idea that there must be a centre, or a border, or a beyond. Flattened. Maybe that's the most valuable part. The analogy. Not that it's perfectly accurate, but that it's a bridge. A soft path from what we know to what we can almost imagine. So if tonight you find yourself picturing the universe, imagine the dots on that balloon again. But this time, forget the room it's in. Forget the lungs that inflate it. Just focus on the surface. Endless, curved, expanding. No edge to fall from, nowhere to arrive but here. You are a dot on that surface. So is every star. And all of us are being carried, together. Not toward an outside, but onward.
If you were to sail across the ocean with no maps, no landmarks, and no sense of where the shore might be, you might start to wonder. Will I ever reach an edge, or will the waters simply curve around forever? In cosmology, we face a similar question. What is the shape of space itself? Now, this might sound like a strange idea. After all, we don't normally think of space as something that can have a shape. But according to general relativity, space isn't just an empty stage, it's flexible. It bends, warps, stretches. And that bending, caused by matter and energy, determines the geometry of the universe. Scientists classify the large-scale shape of space into three possibilities: flat, closed, and open. And while those terms sound simple, the implications are quietly profound. Let's begin with the idea of a flat universe. This means that, on the largest scales, parallel lines stay parallel. Triangles add up to exactly 180 degrees. Space is like a flat sheet stretched across the cosmos, infinite in all directions. No curvature, no loops. Just a vast, endless expanse where the rules of geometry behave just as they did in your old math class. Current observations, especially from the cosmic microwave background, suggest that our universe is very close to flat. If it curves at all, it does so gently, beyond what we can currently measure. Submerged. But suppose space isn't flat. Suppose it curves inward. That gives us a closed universe, one shaped like a sphere in 3 dimensions. It's still without edges, but it's finite. If you could travel far enough in one direction, you might eventually return to where you started, like flying around the globe. The surface of Earth is a closed, 2-dimensional space. A closed universe is the 3-dimensional equivalent. You're always moving forward, yet never escaping. Then there's the third option, an open universe. In this model, space curves outward, like a saddle. It expands forever, but in a way that never loops back. Parallel lines diverge. Triangles don't add up quite the way you expect. It's infinite too, but with a kind of outward drift, more open, more relaxed, less contained. Each of these shapes describes not just space, but destiny. A closed universe could one day stop expanding and contract back into a big crunch. A flat or open universe, on the other hand, may keep expanding forever. The shape tells us something about the future, not just the present. But here's the part that slips gently past our expectations. None of these models require an edge. Whether the universe is flat and infinite, or curved and looping back on itself, or expanding outward with an open sweep, there is no border, no rim, no wall where things fall off. These shapes are self-contained. They define space without enclosing it in anything else. Perhaps even more softly strange, the shape of the universe depends on the way space bends. Like a quilt weighed down in some places, pulled taut in others, the universe is shaped not by its edge, but by its contents. So, tonight, as you think about the shape of the universe, imagine you're walking on a path that never ends, or loops quietly around or splits like a branching stream. No signs, no fences, just the shape of everything, gently curved by everything within it. And whichever shape our universe truly holds, it carries us forward through the stillness of night and the long arc of time in a journey that bends with the stars. When you look up at the night sky, you're not just seeing stars, you're seeing memories. Each pinpoint of light is not just far away in space, it's far away in time. Light travels, but even at its incredible speed, it takes time to reach you. That means everything you see is a glimpse of the past. The farther the object, the older the light. This might sound poetic, but it's also deeply true. Light is a messenger from long ago. Take our sun.
It's about 8 light minutes from Earth. When you glance at it, hopefully not directly, you're seeing it as it was 8 minutes ago. If something dramatic were to happen on its surface, you wouldn't know right away. The news travels with light, and that takes time. The nearest star system, Alpha Centauri, is over 4 light years away. You see it as it was 4 years ago. And some of the galaxies visible in our deepest telescope images, we're seeing them as they were billions of years in the past. Some of them may no longer even exist as they appeared. We're witnessing their ancient echoes. This is what makes astronomy so different from any other science. It's the only one where observing something always means looking into history. Astronomers aren't just stargazers, they're time travelers, piecing together the unfolding of the universe from light that left its source before Earth even formed. Prosecute we look, the older the light. Eventually we reach the cosmic microwave background, a faint glow from when the universe was just 380,000 years old. Before that moment, the universe was too hot, too dense, and too opaque for light to travel freely. It was like a fog of particles. Then it cooled just enough to become transparent, and light, our first light, was set loose. That light has been travelling ever since, stretched and softened by the expansion of space, until it arrives to us now as a uniform glow from every direction, a baby picture of the cosmos. Airborne, really. We build instruments not just to look farther, but to look deeper into time. The Hubble Space Telescope, the James Webb, and many observatories here on Earth are, in a sense, memory collectors. They capture ancient beams of light, storing them like pressed flowers, fragments of stories from the earliest days. And it's not just grand distances. Even here, on Earth, everything you see has a time delay. The moonlight shimmering on water is already over a second old. The light bouncing off a tree across a field is a fraction of a microsecond behind real time. It's so small you don't notice, but it's there. You've never truly seen now, only then. Perpetual, which means, in a way, the universe is always showing you where it's been, not where it is. You're watching a great, slow film made of ancient light, each frame unfolding just a bit further back. So the next time you step outside at night, consider this. Every star you see is a moment preserved. Every flicker is a ghost of what once was. And far beyond those stars, deeper into darkness, is more memory. Still travelling, still arriving, still telling the story of a universe that cannot help but leave its light behind. Let's return now to something quiet, something simple, a small, persistent question tucked gently at the heart of everything we've talked about. What does it mean to be in the universe? We say it casually, we live in the universe, as if it were a house we could stand inside, with walls, a roof, and perhaps a porch looking out over a celestial backyard. But the more we learn, the more that image slips softly away. The universe is not a container. It's not a place we're dropped into. It's not even a thing that holds us. We are not in the universe in the way tea is in a cup. We are the universe, woven from the same fabric, shaped by the same laws, unfolding with the same expansion. You're not sitting inside space like a person in a theatre. You are space. The atoms that make up your body are bound together by forces that came into being with the Big Bang. The elements that form your bones and blood were forged in stars, and the space between those atoms, that too is part of the same ever-expanding reality. It is a strange idea to hold in the mind, because it doesn't feel that way. When you're sitting in your room or lying in bed, the universe doesn't seem to stretch through you. It feels like something out there, cold, vast, and separate. But that's only because our senses were made for the middle scale, for warmth and motion and the distance between a hand and a teacup, not for galaxies or gravitational waves. Has shown us something beautiful, that everything, the room, the teacup, the galaxies, and you, are not separate at all. They are expressions of the same thing, ripples in the same ocean.
And that's why there is no center to the universe, no privileged position. Every point is just as valid as any other. From every galaxy, the rest of the universe appears to expand away. From every planet, the sky stretches in all directions. You could place a telescope on a rock 100 million light years away, and it would tell the same story. We are at the center of our observable sphere, because each observer carries their own. Propelled, this brings us back to the question of edges. If there is no center and no outside, then there can be no edge in the ordinary sense. There's no end of space where you fall off. No final signpost marked "you are now leaving the universe." Just space, stretching and curving and humming quietly to itself. It also changes how we think about our place. We are not near the bottom or the edge or the middle. We are simply here, within it, a local arrangement of matter and thought and breath, moving with the same rhythm as everything else. So when we ask, what's outside the universe, we might also ask, outside of what? Outside of this dance of particles and laws and distance. If the universe is all there is, then outside has no meaning. It's not, because asking is part of what the universe is doing too, through us. So as we leave this first part of our journey, our map of the known, remember this: you are not merely in the universe, you are of it. A ripple in the same sea of light, gravity, time and silence. And maybe, just maybe, that's the most comforting thought of all. Now that we've mapped what we can see, let's step softly into what we cannot. There's a boundary out there, a quiet veil wrapped around the visible universe. It's not a wall, not a line, but a horizon of light and time beyond which our instruments fall silent. We don't know exactly what lies beyond it, but we have ideas. And one of the most important comes from a moment so brief, so strange that it happened before moments even properly existed. Camouflage, inflation. Shortly after the Big Bang, so shortly that the word after barely applies, the universe underwent an unimaginable expansion, not just fast, but exponentially fast. In a fraction of a second, the universe ballooned outward, growing from something unimaginably small to something about the size of a grapefruit, or perhaps a galaxy, depending on how you count. The numbers here are hard to picture, but what matters is the speed, the scale, the strangeness. This period of inflation didn't involve matter flying outward. Matter as we know it didn't quite exist yet. What was expanding was space itself, empty space or something like it, stretching in every direction, doubling over and over and over again. Why do cosmologists believe this happened? Because without it, the universe we see doesn't quite make sense. For instance, if the universe had expanded slowly from the start, different parts of the cosmos would have remained isolated, unable to talk to each other. And yet, the cosmic microwave background, the ancient glow left over from the early universe, is incredibly smooth and uniform, as though everything had coordinated perfectly. Shell solves that puzzle. It says that all the matter and energy we now see came from a single tiny region that was in contact, smoothed out by physics, before being stretched rapidly apart. That's why distant galaxies, separated by billions of light years, still seem to belong to the same calm early rhythm. Another beautiful consequence of inflation is the idea that our observable universe is just a tiny patch, like one snowflake in a vast and invisible blizzard, because if inflation happened once, it may have happened again and again. Some versions of the theory suggest it never stopped entirely, that it's still happening, eternally, in distant places, each pocket of slowed down space becoming its own universe, its own bubble. Minimized in just one of these bubbles. This is where cosmic inflation gently opens the door to the multiverse, the idea that beyond our visible sphere, space continues but with regions that are forever cut off from ours, each one expanding, each one potentially with different laws of physics, different constants, maybe even different dimensions. But let's pause here. Grounded in math and observation are still theories, beautiful ones, powerful ones, but theories nonetheless. We haven't seen other bubbles. We haven't caught inflation in the act. What we have are fingerprints, clues in the sky, whispered through ancient light. So as we sit quietly, wrapped in the warmth of starlight, we can imagine it. A universe that inflated, briefly and wildly, setting the stage for everything we know. And maybe, far beyond the edge of what light has shown us, other bubbles expanding still, silent, unreachable, real. Like distant fires we'll never see, but feel through the patterns they left behind. Let's imagine the early universe again, not as a single event, but as the beginning of something much larger, much stranger. A kind of cosmic recipe that, once started, didn't stop at one universe. It kept going, stirring, bubbling, overflowing. This is the idea of eternal inflation, a theory that expands upon cosmic inflation and gently reshapes the way we think about reality itself. In most versions of inflation theory, space doesn't stop expanding when our universe takes shape. It just slows down locally. Like a bubble forming in a pot of boiling water, our universe is one such bubble, cooling and coalescing while the water around it keeps boiling. The inflation continues elsewhere. New bubbles form, again and again. Astronomical bubbles is its own universe, with its own beginning, its own time, its own laws of physics, perhaps even wildly different ones. Some might contain matter, others might not. Some might be curved or infinite. Some might be fleeting. Some might never slow down at all. Together, they form what physicists call a multiverse. Not just a vast cosmos, but a cosmos of cosmoses. A foamy sea of universes, each sealed within its own growing bubble, separated by ever-expanding stretches of inflating space. Kang, it's a hard thing to picture. Our minds are used to nested ideas, things inside other things. But this isn't a Russian doll, where one universe holds the rest. This is more like soap bubbles blowing in every direction, each unaware of the others, each expanding into space that keeps stretching endlessly between them. In the earlier verse, eternal inflation is true, then the universe you and I inhabit is just one of countless others. One quiet bubble in an eternal storm. It might sound like science fiction, and it has inspired plenty of it, but eternal inflation is grounded in serious physics. The equations that describe inflation don't have a natural stop button. Once it starts, it keeps going, except in rare pockets where it slows down. Those pockets become bubbles, universes like ours. And yet, no matter how elegant the math or how compelling the consequences, we must admit something gently, humbly. We don't know for sure. Not see these other bubbles. Their light, if any exists, would never reach us. The space between bubbles grows too quickly. Even if a neighboring universe exploded with brightness, its glow would be forever lost in the accelerating dark. But here's something quietly poetic. The very idea of other universes comes not from fantasy, but from the attempt to understand this one, to explain its smoothness, its balance, its beginning. The theory that gave us the best picture of our early cosmos, cosmic inflation, also opens the door to others like it, unreachable, unseen, but perhaps real. Some physicists try to test eternal inflation indirectly. They look for tiny fingerprints, oddities in the cosmic microwave background, patterns that might suggest our bubble once bumped into another. So far, there's nothing conclusive. Just hints, possibilities, and a great deal of silence. Plus or minus, and maybe that's how it will stay. Maybe eternal inflation is a truth we'll never observe directly. But the idea remains. Quiet, expansive, a reminder that even the biggest thing we know, our universe, might be part of something even larger, something we'll never touch, but can still wonder about. Like listening to the sound of one wave and imagining the ocean. Let's drift now into a realm that stretches not just beyond what we can see, but beyond what we can imagine in 3 dimensions. A place where our universe isn't all there is, not even in the sense of many bubbles floating in space, but in a deeper, stranger way. A place where our entire universe might be just one surface, a membrane within a higher dimensional space. This is the world of brane cosmology. Discontent comes from membrane, a term used in string theory to describe objects that can have any number of dimensions. A zero brane is like a point, A one brane is a line, a two brane is like a sheet, and a three brane? That's what some physicists propose our universe could be, a three-dimensional surface floating in a higher dimensional space, sometimes called the bulk. That's thing to picture, but imagine a soap bubble again, not just as a surface in air, but as a kind of dimensional membrane within a larger structure. On that surface, everything you know exists. Every galaxy, every planet, every person. You can move in three spatial directions, left and right, forward and back, up and down, but you can't leave the surface. Not because of walls, but because the laws of physics, the very threads of gravity and light, are bound to that surface. That's how brane cosmology works. We are part of a universe that may be trapped or anchored to a higher dimensional brane, and outside of it, in dimensions we cannot access, other branes may exist, other universes, other realities. Some might be parallel to ours, others might drift slowly toward us or away, and once in a while, just maybe, they might collide. Versions of this theory suggest that the Big Bang itself might not have been a beginning, but a collision, a smash between two branes in a higher dimensional space. The energy released in that moment could have given rise to the hot, dense state from which our universe expanded, a cosmic clap echoing through unseen dimensions. It sounds fantastical, and yet this idea arises naturally from string theory, a framework that tries to unify all the forces of nature, from gravity to electromagnetism, into a single, elegant picture. String theory suggests there may be more dimensions than we perceive. Not just the three of space and one of time, but as many as 10 or 11, tightly curled and hidden from view. In those extra dimensions, our universe might be a floating sheet, a brane, and we, everything we know and are, would be ripples on its surface. Transporting, like many ideas at the frontier of physics, brane cosmology remains a theory, elegant, compelling, and still speculative. We haven't yet found direct evidence for extra dimensions or for other branes drifting through the bulk, but physicists have proposed experiments, tiny signs in particle collisions or gravitational waves that might one day give us a glimpse. Flooring then, it remains one of the most hauntingly beautiful possibilities. That we are part of something larger, not just spatially larger, but dimensionally deeper. That beyond the thin, familiar curtain of our universe lies a reality we can't yet touch, but might someday feel. So tonight, as your mind settles and floats, imagine this: a great invisible sea, rippling with unseen waves, and in it, a delicate surface, our universe, gently gliding, carrying you quietly through a dimension you cannot name, but are already part of. Now let's take another quiet step, this time not into outer space, but into the nature of reality itself. A reality that may not be quite what it seems, because there's a theory, both bold and delicately mathematical, that suggests our three-dimensional universe might actually be a kind of illusion, a projection, a shadow cast from a more fundamental surface. This is the holographic principle. It sounds like science fiction, but it began, as many of these ideas do, with a puzzle, a black hole puzzle. In the 1970s, physicist Jacob Bekenstein noticed something strange. The amount of information, what physicists call entropy, that could be contained inside a black hole didn't scale with the volume of the black hole as one might expect. Instead, it scaled with the surface area of its event horizon, the invisible boundary beyond which nothing can escape. That's like saying everything you need to know about what's inside the black hole can be encoded on its outer skin. Leet Narken confirmed this by showing that black holes emit radiation, what we now call Hawking radiation, and that they obey thermodynamic laws just like more ordinary systems. And this led physicists to ask, what if this surface area rule isn't just for black holes? What if it applies to the universe itself? Framed the holographic principle, it proposes that all the information contained within a region of space can be described by data that exists on the boundary of that region, like a cosmic shell, just as a 3D hologram can be generated from a 2D plate. Our 3D universe might be the result of information encoded on a distant two-dimensional surface, knocking metaphorically, literally. They say the same thing. We don't know if our actual universe works this way. The ADS-CFT model applies to a kind of curved space that isn't quite like our own, but the idea lingers. Haunting. Humbling. If the holographic principle is true, then reality as we know it is emergent, arising from something more abstract, something written on a kind of cosmic screen we'll never see. And you, your body, your thoughts, your sense of here, could be part of that projection. Not less real, just differently real. So tonight, as you rest, imagine the universe as a great hall. You're inside it, moving through light and space and time. But on its faraway walls, encoded in something far finer than language, your story is already written, not in contradiction to your experience, but as its quiet foundation. And maybe the edges of the universe aren't edges at all. Maybe they're where the story begins. What if the fabric of reality, space, time, everything, were made not of points or particles, but tiny, vibrating strings? This is the premise of string theory, one of the most ambitious attempts ever made to describe the universe in a single, unified language. And though it's deeply mathematical and often dizzyingly complex, it opens a door into a vision of the cosmos that stretches beyond what we can see, touch, or even directly test. A vision that might help us understand what lies beyond the known horizon, not just beyond stars, but beyond dimensions. In string theory, all fundamental particles, electrons, quarks, photons, aren't truly points with no size. Instead, they're tiny, one-dimensional strings, vibrating in different ways. One frequency of vibration produces a photon, another gives rise to a neutrino, like different notes played on a cosmic violin. But there's a twist. For these strings to work, mathematically, the universe needs more dimensions than we're used to. Not just 3 dimensions of space and 1 of time, but 10 or even 11. Most of these extra dimensions are thought to be curled up, compact, so small we don't notice them, like a garden hose that looks like a line from far away, but reveals a tiny circle when you zoom in. Leads to the idea of the bulk, a higher dimensional space in which our universe, as we know it, is embedded. We might be living on a 3-dimensional brane floating inside this larger bulk. The matter, forces and light we experience are confined to our brain, but gravity might not be. It could drift into the extra dimensions, leaking away, explaining why it's so much weaker than the other forces. And what lies in the bulk? Possibly more brains, more universes, other realities with their own laws of physics, separated not by distance but by dimension. Minimized she imagining sheets of paper stacked together, each one a universe with no easy path from one to the next. We're confined to our page, unaware of the pages beside us. But maybe gravity ripples faintly through them. Maybe particles near the edge feel a gentle tug. Maybe, sometimes, 2 brains pass close enough to interact, creating cosmic events we can't yet explain. Blackmail are variations of string theory, M theory for example, that suggest even membranes themselves can vibrate and collide. Some physicists believe that these collisions could spark new universes, new cycles of expansion and rebirth. In this picture, our Big Bang was not the beginning of everything, but the result of 2 brains brushing against each other in the bulk, a soft collision with profound consequences. Of course, all of this, beautiful as it is, remains unproven. These extra dimensions may be forever hidden. The bulk may be mathematically elegant, yet physically unreachable. But string theory remains one of our best tools for imagining what might lie beyond the visible, beyond the known, beyond the very shape of space, as we understand it. And maybe that's what the horizon truly offers us. Not just a limit, but a question, a shimmering edge that invites us to listen more closely, to feel for echoes in gravity, to trace patterns in particles, to wonder. Thoughts slow. Imagine reality not as a single surface, but as part of a grander architecture, a structure woven of strings and membranes and hidden dimensions. Picture your universe floating gently in a higher dimensional sea, curved and quiet, its surface rippling like silk. And somewhere beyond, perhaps, another universe drifts softly beside our own, not beyond the stars, but beyond the space that holds them. We often imagine the universe as a one-way story, beginning with the Big Bang, stretching outward, cooling down, and eventually fading into a quiet, distant future. But what if that story isn't a straight line? What if, instead, it's a cycle, a breath, an inhale, and an exhale of everything that exists? This is the heart of cyclic cosmology,
a family of theories suggesting that the universe has no true beginning or end, only endless phases. Expansion, collapse, bounce, and repeat. Let's begin with cycles are everywhere. You see them in the rising and setting of the sun, in the seasons that turn, the tides that rise, the breath that moves in and out of your chest. Even the cells in your body operate on rhythmic patterns. Nature rarely draws just one line. It prefers circles, spirals, returns. Cyclic universe theories propose that the cosmos might be no different. Instead of a singular Big Bang, launching all of space and time in one grand motion, the universe might go through cosmic cycles, expanding, slowing, contracting, and then bouncing back into a new expansion. In some versions, the universe grows until it reaches a point of maximum stretch, then contracts in a big crunch, eventually collapsing under its own gravity into a hot, dense state, not unlike the Big Bang. But instead of an end, this moment gives birth to the next universe. Other models, including some inspired by brane cosmology, suggest a gentler process. Two higher dimensional branes could drift toward each other, collide, create a Big Bang-like event, then move apart again, cooling and expanding. Over time, they drift back once more, and the cycle begins anew. These collisions don't require a collapse, just a rhythm, a dance of universes brushing into being. There are even quantum versions of cyclic cosmology, where the universe never truly hits a singularity, never truly becomes infinitely dense, but instead reaches a smallest possible scale, dictated by quantum gravity. At that moment, it bounces, and the arrow of time reverses direction. These ideas are still in development. The math is complex, and the evidence is subtle, but they offer something quietly profound, an alternative to the loneliness of a one-shot universe. A cosmos that doesn't simply fade into entropy, but renews itself, again and again. Reframes the Big Bang. In a cyclic universe, the Big Bang isn't a singular miracle, but one note in a repeating song, one heartbeat in a cosmic rhythm. We are living in a chapter, not a prologue, not a finale. That isn't there. Still, cyclic models face challenges. The second law of thermodynamics tells us that entropy, disorder, should always increase. Wouldn't each cycle become more stretched, more diffuse, eventually too diluted to bounce again? Some versions of the theory try to resolve this by stretching time or resetting entropy between cycles, but the question remains open.
Even so, the idea lingers, gentle and looping. Maybe the universe breathes. And if it does, then this moment, this particular version of space and time, stars and atoms, thoughts and questions, is part of that breath, one motion in an infinite pattern. So tonight, as you breathe in and out, let yourself imagine the universe doing the same, quietly expanding, quietly collapsing. And in between, a pause, a stillness, before it all begins again.
Now let's enter a realm where reality itself begins to blur, where the future is not fixed, and every possibility might be more than just a might have been. In this realm, asking what's beyond the edge of the universe opens up something even stranger. Not a place, but a branch. And the quantum multiverse, a concept born not from cosmology but from quantum physics. It suggests that every quantum event, every tiny decision made by particles at the smallest scale, causes the universe to branch, again and again, into an ever-splitting tree of worlds. To understand this, we have to revisit a quietly strange idea at the heart of quantum mechanics. When particles are not being observed, they don't seem to be in one state or another. Instead, they exist in a superposition, a blend of all possible states at once. It's not that the particle is here or there, it's both, until a measurement forces it to choose. But in the many worlds interpretation, that choice doesn't eliminate the other options. Instead, it splits the universe. In one universe, the particle lands here. In another, it lands there. Both outcomes are real, both happen, but each in a different branch. Confined, stretch that idea. Imagine every decision, every event, quantum or not, splitting the world in two, or 10, or a million. You choose coffee instead of tea, and somewhere else, another version of you lifts the teacup. You turn left instead of right. You send the message, or you don't. And each fork spawns a new universe. It's a dizzying picture. Not a cosmos of galaxies drifting in an expanding sea, but a quantum forest, endlessly branching. So where are these other universes? Plight, they're not elsewhere in space. You can't get to them by flying far enough. They're alongside this one, in a space not of distance but of possibility. They are inaccessible, yet just as real. According to the theory, they exist within the mathematics of quantum mechanics itself, like musical harmonies you'll never hear, but that shape the song nonetheless. Physicists find this idea unsettling, others find it elegant. It removes the randomness from quantum mechanics. No need for mysterious collapse or hidden variables. Everything happens, just not all in the same thread. This version of the multiverse is different from the eternal inflation bubbles. Those are separated by space. These are separated by branching choice. Unlocking together, they weave a very full universe. A space of not just stars and galaxies, but of paths, of every possibility, lived out. But again, we must be gentle with our certainty. The quantum multiverse is a way of interpreting known physics. It explains the math, but it's not the only explanation. And we don't yet know how, or if, it could be tested. It may forever remain an idea we can explore only with thought, and not with tools. Still, there's something quietly beautiful in it. That every possibility is honoured. That no choice, no outcome, no version of you is ever truly lost, just travelling another thread of the weave. So tonight, as your thoughts wander, you might imagine that there are countless versions of this very moment. Somewhere, a you who didn't press play, a you who's already asleep, a you listening again, years from now, remembering this gentle curiosity, that the universe may not be a single story, but an infinite library. And this, right here, is one quiet page. For all the beauty and strangeness of multiverse theories, higher dimensions and cosmic bubbles, we eventually return to a quiet question. How would we ever know? If these other universes, these other branes, these ghostly quantum branches exist, could they leave a mark, a whisper, a ripple in the silence? Thanks this too, not with poetic hope, but with equations, data and sky maps. They look for echoes, subtle signatures in the structure of our universe that might hint at something beyond. One of the most studied places to look is the cosmic microwave background, that faint glow left over from the Big Bang, still shining from every direction. It's like the universe's baby picture, and it's incredibly smooth, but not perfectly so. There are tiny fluctuations, gentle spots of warmer and cooler radiation. These are thought to be the seeds of galaxies, shaped by quantum ripples in the earliest moments of time. Some theorists have wondered, what if a neighbouring universe, another bubble, once brushed up against ours? Would it leave a mark, a scar, a ring-shaped anomaly in the background glow? Teams of scientists have searched for exactly that. They've combed through satellite data, WMAP, Planck and others, looking for unexplained circles, patterns or temperature distortions. So far, the results are inconclusive. Some curious features have been found, but none have been confirmed as anything beyond statistical noise. Still, the idea lingers, that somewhere in the sky might be an echo of a collision with another reality. Other efforts focus on gravity. If extra dimensions exist, they might affect how gravity behaves, especially on very small scales. Some experiments have tried to measure whether gravity weakens more quickly than expected, hinting that it's leaking into other dimensions. The results? Again, mostly silence. But the questions remain open. Turbulence, there's even speculation that black holes might be gateways, portals to other branes or dimensions, not in the sci-fi sense of ships flying through, but in the mathematical sense. If information isn't destroyed in a black hole, where does it go? Could it cross into another universe? Or return as Hawking radiation, encoded and scrambled? And what about quantum experiments? Could we ever test the many worlds interpretation? Could we build a device sensitive enough to catch the briefest interaction with a parallel branch of reality? Plunge yet. Maybe not ever. These ideas sit on the edge of what science can currently touch. But that doesn't make them useless. They stretch the boundaries of thought. They shape how we interpret what we can observe. And occasionally, they guide new predictions, new ways of understanding what's right in front of us. Because science doesn't always begin with proof. It often begins with a question, a hunch, a sense that the pattern might be more than it appears. Microscopic. Imagine the sky as a great canvas of shadows and reflections. Some marks are clear, others are smudges barely seen. But all of them whisper of a deeper structure, one that might include other universes or other ways of being just beyond the edges of our reach. And whether or not we ever detect them, we carry the wonder, that soft echo in the mind that asks not with urgency but with awe, what else is out there?
When we say the universe is expanding, it's natural, almost irresistible, to ask, into what? It feels like there must be a surrounding emptiness, a vast nothingness into which galaxies drift, as though the universe is a balloon and space is the air it's pushing into. But this image, gentle as it is, quietly misleads, because in truth space isn't expanding into anything at all. It's simply expanding. And step back. Picture two galaxies, not flying away from each other like ships through the sea, but sitting still while the sea between them stretches. That's what cosmological expansion means. Not that things are moving through space, but that the space between things is growing. There's no need for a larger arena surrounding it all. A company is one of the hardest concepts in cosmology, because every experience in your life suggests that things need space to grow into. A seedling needs soil to push roots into. A puddle needs ground to spread across. Even your thoughts seem to float through mental space. So when we hear expansion, we instinctively reach for metaphors. The balloon inflating, raisins in rising dough, a ripple in a pond. These metaphors help, but only part way. They imply a larger context. Air around the balloon, a kitchen counter under the dough, water around the ripple. And in doing so they smuggle in the idea of an outside. Disarm. But the universe doesn't have an outside, not in the way we mean. Flushed according to general relativity, space-time is not a substance in a container. It's the container and the contents. It defines distance, direction, and time itself. You can't meaningfully ask what space expands into, because space is the framework in which such questions make sense. There's no beyond for it to reach toward. One way to ease this idea in is to imagine a two-dimensional creature, let's call it a flatwalker, living on the surface of a balloon. To flatwalker, the world is a two-dimensional skin. As the balloon inflates, it sees everything stretch away. But it can't climb off the balloon. It doesn't even know there is an off. The third dimension is inaccessible. From flatwalker's perspective, there's no outside, just more balloon appearing between points. We are the same, in 3 dimensions. We're not moving outward. The distances between galaxies are growing because the metric of space is changing, not stretching into a higher void, but expanding within itself. But even in those models, the expansion doesn't need an outside to be real. The math works from within. The movement happens without motion through anything. Stretches, not from center to border, but everywhere at once. So tonight, if your mind tries to picture the universe expanding outward into some vast surrounding dark, you can gently let that image dissolve. Replace it with something softer. Not an explosion through space, but a blooming of space. A deep breath that never needed a room to happen in. It expands because it does. And that is enough. Let's shift our gaze now, not to space itself, but to the shapes we use to describe it. Because when we ask, does the universe have an edge? We're really asking something deeper about geometry, about boundaries, about how space can be shaped without needing to be wrapped in a box. To begin, imagine something familiar. A sphere, not a ball with volume, but just the surface of a ball, like the skin of a planet. It's two-dimensional, curved, and crucially, it has no edge. You can walk in any direction forever and never fall off. There's no wall, no border. Just continuous space that curves gently back into itself. Now imagine a torus, the shape of a donut. This too is a surface with no edge. If you walk forward long enough, you return to where you started. And again, there's no border, just a different kind of looping. These are examples of topology, the mathematical study of spaces not based on their exact size or curvature, but on their connectedness. A topologist doesn't ask how long something is, but whether it has holes, whether you can stretch it without tearing, whether you could turn a coffee mug into a donut if the clay was soft enough and you didn't mind a little squish. In topology, a space can be finite and still have no edges. That's the magic. A sphere isn't infinite, but you'll never reach a wall. It's bounded by its own structure. Demolished. Now here's a playful twist. Many video games use this logic too. Think of an old arcade game, maybe a space shooter or a maze, where if you fly off the right side of the screen, you reappear on the left. Step off the top, and you arrive at the bottom.
This isn't a trick. It's a flat representation of a toroidal space, a wraparound universe, finite but boundless, edgeless even though your screen ends. Mathematically, there are even more exotic topologies, three-dimensional spaces that loop in strange and elegant ways. Some might resemble twisted prisms or Mobius strips. Some might have paths where you can return not just to the same place, but mirrored or rotated. These aren't just thought experiments, they're legitimate candidates for how space might behave on a cosmic scale. So what does this mean for the universe? Well, the observable universe, the part we can see, is a sphere, but that's just due to how light reaches us. The universe as a whole might be infinite, or it might be a finite, topologically closed space, like a 3D version of a torus or a sphere. If it is, you could travel in a straight line forever and, in theory, return to your starting point. You'd never see an edge, never hit a wall. In fact, there are some speculative models where the universe is smaller than the observable universe, meaning that light could loop around, giving us multiple images of the same distant galaxies from different angles, like mirrors in a funhouse. Buckley haven't found conclusive evidence of that, but the math allows it, and the idea remains one of the many possible shapes of everything. So tonight, as you imagine the universe, don't picture a map with corners, or a vast room with walls. Instead, think of a shape that wraps quietly around itself, a space that's whole and continuous, one where the idea of edge simply doesn't apply. You are not standing near the border of reality. You're already inside the shape, and the shape may never need to end. If you've ever watched a marble roll along the curve of a bowl, or seen ripples on the surface of a trampoline, then you already understand something beautiful and quietly profound: the way space bends. In our everyday world, an invisible force tugging apples from trees, anchoring oceans to earth, keeping your feet gently pressed to the floor. But in the language of general relativity, gravity isn't a force at all. It's a curve, a shape, a soft warping of space and time itself. Einstein taught us that mass and energy don't just float in space, they tell space how to bend. And then, space tells matter how to move. Imagine laying a blanket across a table and placing a heavy ball in the centre. The fabric dips, forming a gentle curve. Now roll a smaller ball nearby. It spirals inward, not because the large ball pulls on it, but because it's following the natural slope of the surface. The path of least resistance, the straightest line available, on a surface that isn't flat. Gravity works on the cosmic scale. Planets orbit stars not because they're being tugged like fishing lures, but because they're moving along the curves carved by the star's mass. Galaxies swirl because the fabric of space itself is shaped by everything within it. But here's the part that matters for our question. Space doesn't need something outside to curve. The blanket doesn't need to be in a room for the curve to be real. It curves within itself. Its geometry is intrinsic. This means the universe doesn't require an external dimension to bend or flex. It doesn't need to float in a higher realm. The curvature of space-time is self-contained, defined by the presence of mass, energy, and pressure. The shapes of galaxies, the paths of light, the aging of time, all of it happens inside the system, no outside scaffolding required. And that's part of what makes general relativity so elegant. It replaces the old Newtonian view, where gravity reached across emptiness like invisible hands, with a geometric view, a graceful dance of motion through curved space, even curves. Photons, massless particles of light, always move in straight lines, but when space itself is bent, those straight lines twist, like headlights bending through a warped window pane. That's why we see gravitational lensing, light from distant galaxies distorted around closer objects, their paths curved not by force, but by shape. Whether the universe has an edge or what it might expand into, general relativity gently invites us to stop imagining a container. There is no surrounding box, no higher room in which the cosmos must float. Flattened, the universe curves where it needs to, grows as it must, and its motion follows the shape of the fabric it weaves for itself. You are part of that fabric. Every breath, every blink, every thought you've ever had has unfolded within these curves. The ground you walk on, the stars you see, the silence between them.
all of it shaped by the great invisible geometry of space-time. And so tonight, if you find yourself picturing the universe as a bubble inside something bigger, let that image go. Instead, picture a path, graceful and curved, traced through a surface that has no edges, only direction, only motion, only form. We are not in space like raisins in dough, we are space, shaped into stars and thought and wonder, held not by walls, but by the soft curves of the cosmos. Now let's turn our gaze inward, not into space but into time. You might have heard the question before, or perhaps asked it yourself, quietly late at night. What happened before the Big Bang? It's such a natural question. Everything in our experience has a before. Breakfast comes before lunch, childhood before adulthood, a raindrop before a puddle. So when we hear that the universe began with the Big Bang, our minds reach back. Before stars, before atoms, before even light, and we ask, what was there? Positioned to modern cosmology, the answer may be nothing. Not because it was empty or quiet or waiting, but because there was no before to begin with. Time itself, our most basic rhythm, may have started with the Big Bang. Tightened to understand this, we need to loosen our grip on time as a backdrop. In our daily lives, we treat time like a hallway we walk through. Events happen along the way, but the hallway itself is always there, infinite in both directions. But in physics, especially in general relativity, time isn't separate from the universe. It's part of the same fabric as space. Together they form space-time, a dynamic interwoven stage that flexes and flows depending on the mass and energy within it. So when we say the Big Bang was the beginning of the universe, we don't mean it exploded into time, we mean time began with it. There is no earlier, not because we haven't looked far enough, but because there may be nothing to look into. Breached. It's a bit like asking, what's north of the North Pole? The question feels valid, but it falls apart under closer thought. The North Pole is already the top. Once you're there, every direction points south. North of north doesn't make sense, not because it's mysterious, but because it's undefined. Similarly, the Big Bang is not just the start of stuff, it's the start of space, the start of measurement, the start of change. It's the boundary not in space, but in time. Not a bang like a firecracker in the void, but a boundary like the surface of a balloon, the point from which all moments stretch. Of course, the closer we get to that boundary, the fuzzier things become. The laws of physics we rely on start to break down. Quantum effects, gravity, temperature all begin to blend in strange ways. This is where physicists turn to theories of quantum gravity, hoping to describe the earliest instance of the universe. Some of these models suggest time may have emerged from something else. Others imagine a bounce, or a prior phase that doesn't resemble anything we know. But even in those models, time as we experience it, linear, flowing, measurable, still begins at that threshold. So when we ask what came before the Big Bang, we're leaning on the language of everyday clocks. But clocks are born inside the universe, not outside of it. Asking about before the universe is a little like asking what's south of south, or what happens 1 second before the first second of time. It's not just a question of knowledge, it's a question of definition. And maybe that's where the wonder truly lies. Condemned, let your thoughts drift not into the past, but to the very edge of time itself. Not a cliff, but a curve. A soft beginning where time, space, matter, and even questions themselves first unfolded. Bond that curve, displace nothing. Not empty nothing, not dark nothing, just know where and know when. A silence before silence. You are. As we've journeyed outwards toward the edge of the universe, and inward toward the beginning of time, you might expect there's no place left to go. But there's one more direction we haven't yet travelled. Smaller. Let's take that step now. Not out into the vast, but down into the microscopic fabric of reality. To the scale where space, time, and matter may not behave like anything we know. Where our familiar rules dissolve, not into chaos, but into mystery. Millions is where we find the Planck scale. Named after physicist Max Planck, this scale defines the smallest meaningful units of space and time, as determined by the constants of nature. The Planck length is about 1.6 times 10 to the 30 power 5 meters. The Planck time, about 5.4 times 10 to the 30 power 5 seconds. These numbers are almost absurdly small. many orders of magnitude beyond anything we can currently measure. But they're not just tiny. They represent a limit. Why? Because below the Planck scale, the very idea of measurement may stop making sense. This gently vibrator as a calm sheet of water. On the scale of galaxies, it's smooth. Even on the scale of atoms, it seems steady. But as you zoom in, far past quarks, past the nucleus of an atom, past the smallest particles, something happens. The sheet begins to ripple, tremble, foam. This is what some physicists call quantum foam, the idea that at the tiniest scales, space-time isn't smooth, but chaotic, bubbles of temporary particles flickering into and out of existence, miniature warps and tunnels, a sea of uncertainty. At these depths, the classical idea of a point in space, something you can label with exact coordinates, begins to blur. Quantum mechanics introduces uncertainty. General relativity adds curvature. And together, they create a paradox. Try to measure space too precisely, and you need so much energy that you create a black hole. Your ruler folds in on itself. Debye. This is the Planck wall, not a barrier like a fence, but a boundary in what physics can describe. We don't yet have a complete theory that unifies gravity with quantum mechanics, but many physicists believe that below the Planck scale, space and time themselves may be quantized, made of discrete bits like pixels on a screen. Not continuous, but granular, a kind of fabric with a smallest thread. And if that's true, then there's a bottom to measurement, a smallest unit of where, a briefest moment of when. Below that, the question loses meaning. So when we wonder about the limits of the universe, we must remember, edges aren't only about far, they're also about near. We may never reach the end of space, but we may never resolve the beginning of a point. Both directions, outward and inward, carry their own kind of mystery. And this is the quiet symmetry of the cosmos, that the very large and the very small reflect each other. The curvature of foam at its foundations, boundaries not in distance, but in comprehension. So tonight, as you settle into stillness, imagine the tiniest fragment of reality, not a thing but a ripple, not a place but a limit, a whisper of scale where space forgets how to be space, and time becomes uncertain. And then let that thought go. And just, sometimes, the most comforting thing is not knowing what lies beyond the edge, but knowing there is an edge, even to knowing. For most of human history, we've used language like a lamp, something to shine onto mystery, to reveal what hides in the dark. But sometimes language casts more shadows than light, especially when we talk about the universe. We say it expands, that it has a beginning, that it might have an edge, or that there could be an outside. These words feel solid, familiar. They help us build a picture in our minds, a balloon, a room, a timeline. But beneath them, the ground shifts. Comes to the cosmos the words we borrow from everyday life, walls, centres, borders, before and after, often begin to break down, and in their place we turn to something else. Not poetry, but precision. Not metaphors, but mathematics. Mathematics is the true language of physics. It doesn't care whether you can picture it or not, it just is. A line can be infinite in both directions, a space can be curved in 4 dimensions, a function can describe entropy without knowing what toast or teacups are. Math is silent but clear, cold but exact. Still, most of us don't live in equations, we live in stories, in experiences. So we build bridges between math and meaning. We say space is like a fabric, time is like a river, expansion is like rising dough. These metaphors are helpful until they aren't. Before the idea of a centre, in a city there's often a main plaza. In a circle there's a clear middle. So we imagine the universe must have a centre too, but the math tells us otherwise. In an infinite or uniformly curved space, every point is equally valid. The expansion doesn't happen from a central dot, it happens everywhere at once. There is no cosmic downtown. Or consider outside. Every day we move from inside to out the door, out of the house, out into the world. So it feels natural to ask what's outside the universe. But in math, a space can be complete without being inside anything. A surface can loop. A function can define a structure fully within itself. There's no need for a surrounding shell. Disproportionate.
The word beginning gets tangled. In most stories, beginnings are events, openings in time. But with the Big Bang, we're not talking about something that happened inside time. We're talking about the emergence of time itself. That's a hard thing to wrap language around, like trying to write the first word of a sentence with no alphabet. It leaves us gently between two languages, one that's comforting and familiar, and one that's alien but accurate. We need metaphors, we always will. They guide us through the fog, give our minds something to hold. But we also need to remember, they are tools, not truths. A metaphor is a stepping stone, not the destination. Know this, that's why so much care is taken when explaining difficult ideas. Why even the most poetic descriptions are often followed with, but that's not quite right. Because they know the universe doesn't owe us clarity in our native tongue. It just is, and we must find the language to meet it. So tonight, if you find your mind chasing after phrases like edge of the universe or outside of space, pause for a moment. Listen for the silence beneath the sentence. There you might find something even more honest. Not a perfect description, but a patient question. And maybe the real boundary isn't out there at all. Maybe it's in here, in the limits of the words we use to understand what cannot be fully spoken. We've arrived now at the quietest part of the question. Not the edge of the universe or the limit of space or the first tick of time, but the edge of understanding itself. A place where the words we've used outside, beyond, before, start to fold in on themselves like paper creased too many times. Soft, fragile, unfoldable. Let's return one more time to that persistent question. What exists outside the universe? It sounds reasonable, clear, even childlike in its curiosity. But here's the twist. When we ask that, we're not just looking for an answer, we're assuming the question itself makes sense. And perhaps it doesn't. To understand why, consider what the word outside means. It's a relational term. You're outside the house, outside the room, outside the car. It only works when there's a space to step out of and a space to step into. It relies on a boundary between two somethings. But when we speak of the universe, we're speaking of everything. Not just matter and galaxies, but the space that contains them, the clock that ticks between events, the laws that allow anything to be located at all. If something exists outside the universe, what would it be made of? Where would it be placed? In what time would it occur? Not just difficult questions, they may be meaningless questions, grammatical in form, but without reference. It's a bit like asking, what colour is the number 7? You can say the sentence, you can picture it in your mind, but unless you have synesthesia, it's not a question that tracks with reality. Numbers don't have colour. The question doesn't fail because of ignorance, it fails because it doesn't apply. Or imagine trying to walk north from the North Pole. You can turn in any direction, you can take a step, but north no longer means anything. You've reached the conceptual limit of that direction. Discharge what's outside the universe, maybe just like that. Even among physicists and philosophers, this is a known tension. Some will say the question is undefined, others will try to reformulate it. What lies beyond our observable universe? Or are there other universes governed by different laws? These are questions we can try to address. They have shape. They ask about parts, not outsides. But the original question, outside the universe, leans on a spatial metaphor that may simply not apply. And if it doesn't apply, then no answer, however poetic or mathematical, will satisfy it. This may sound limiting, but it can also be quietly liberating, because it reminds us that language is not the sky. It is a net, a beautiful, flexible, shimmering net, but some things are too wide, too deep, too strangely shaped to be held by it, and that's okay. The universe, then, may not be a place at all. It may be a pause, a place where we breathe, where we let go of the chase for where, and rest in the awareness that some questions are not unanswered, but unanswerable. Not as a failure, but as a form of awe. So tonight, let yourself stand at that pause, not with frustration, but with wonder. The universe may have no outside. It may not even need one. And here, in this quiet boundary between knowing and not knowing, is a space of its own. Not beyond the stars, but within your own thoughts. A space made not of matter, but of mystery.
And that, too, is part of the universe. If you step outside on a clear night, far from city lights, and look up, you're not just looking into space, you're looking into time. That gentle twinkle of starlight, it's old. Even the closest stars are years away, light years to be precise. The light you see left them long before this moment. Some left before your first birthday. Some before the first human ever stood upright. Some before Earth itself had oceans. We think of telescopes as tools that help us see far, but what they really do is help us see back. The farther we look, the further into the past we go. Galaxies a billion light years away? We see them as they were a billion years ago. Not because they've changed since, though they have, but because the light that shows their change simply hasn't reached us yet. This is the nature of the observable universe, a bubble defined not by space, but by time. Specifically, by the amount of time light has had to travel since the Big Bang. That's why it has a radius of roughly 46 billion light years, not 13.8 billion. Space has stretched since that first light began its journey. But this leads to a quiet realization. What we can see is not all that exists. In fact, it may only be a small fraction. Beyond the edge of the observable universe, more stars burn, more galaxies spin, more space expands. But their light simply hasn't had time to arrive. And for some of them, it never will. They are too far, moving away too fast, across a space that is itself stretching faster than light can cross it. So when you imagine the universe, don't picture a globe with galaxies filling it neatly and stars blinking along its surface. Picture something stranger, a growing sphere of what we can see, surrounded by an invisible beyond. A beyond that doesn't glow in our instruments, but which may still be real. When you look at a galaxy 2 billion light years away, you're not seeing what it looks like now. You're seeing what it looked like when life on Earth was just beginning to form complex cells. You're looking at its fossil light, frozen in time, stretched by distance, echoing through space. This is why astronomers speak so often in the past tense. They study things not as they are, but as they were. The telescope isn't a window, it's a time machine. It's humbling, really, but we see only the past. The universe reveals itself not all at once, but slowly, like stories unfolding through delayed letters. Each beam of light, a message from long ago. The stars above are not where they seem. Some may no longer exist. Some may never be known. But their light is here, brushing your eyes gently, crossing eons just a whisper, minimized. Now let's drift toward the farthest edges of the visible universe, toward the dimmest galaxies, the most ancient starlight, the last photons that can still reach us. And beyond them, we find not silence, but something strange. Hacking, not stillness, not slowing, but acceleration. You might expect that over time gravity would pull everything back together, that the expansion of the universe would gradually slow like a ball tossed into the air, that galaxies tugging on each other would inch towards stillness, that eventually things might even reverse. Parking, that's not what we see. In the late 1990s, astronomers studying distant supernovae, bright explosions in remote galaxies, noticed something unexpected. These ancient explosions were dimmer than predicted, not because the stars were faint, but because they were farther away than they should have been, given how fast the universe was expanding when their light began travelling. This meant one thing: the universe wasn't just expanding, it was accelerating. Somehow was pushing space apart more and more with time. Galaxies weren't coasting outward, they were speeding up, not because of momentum, but because of some repulsive force woven into space itself. We call this mysterious presence dark energy. It makes up about 68% of the total energy content of the universe, and yet we don't know what it is. It's not matter. It doesn't clump, it doesn't glow, it doesn't slow down, it doesn't even dilute as space expands. It simply persists, a steady pressure stretching the fabric of everything.
It changes what we can ever know. Submerged. As the expansion accelerates, more and more of the universe slips beyond our horizon. There are galaxies, even now, whose light will never reach us, not because they're too far, but because they're receding faster than light can catch up. Their signals stretch into invisibility. Their presence becomes unreachable, not just distant, but lost. Bailey of instruments or a challenge of technology, it's a fundamental limit, etched into the nature of space-time by dark energy. Priesthood, and it means that our observable universe is not just a bubble of light, but a shrinking window into what was once connected. With each passing eon, more galaxies will vanish from view, not by moving but by falling beyond the edge of light's reach. Eventually, only our own galaxy, and those gravitationally bound to it, will remain visible. The rest will become whispers in the dark, a sky growing quieter. Confiscatedcists call this the cosmic event horizon. Not unlike the edge of a black hole, once something crosses it, its light will never reach us. It hasn't vanished, but it has become forever inaccessible. And yet, we know it's there. Confiscated because we've seen the supernovae, measured the redshift, watched the galaxies pull apart like lanterns floating on a stretching sea. It kind of loss, a fading not from destruction, but from expansion. A parting without violence, without goodbye, just distance deepening endlessly. So tonight, if you find yourself wondering what lies at the edge of the universe, remember this. Some of it is already gone. Not destroyed, just gone from us. The edge is not a place of endings, but of slipping. And you, sitting here, still able to see so much, are living in a brief and precious moment. A time when the stars still speak. When their ancient light still crosses the sky. When the cosmos, though widening, still shares its story. And you are listening. Imagine walking into a vast ancient library, hoping to find its oldest book, the very first story ever written. You move from shelf to shelf, the volumes growing more yellowed, more brittle, and just as you reach for the oldest tome, you find a wall, a soft glowing mist. Behind it, everything is blurred, hidden, out of reach. Bangkok. This is what happens when we look to the earliest light in the universe. We don't see the beginning directly. We see a glow, a cosmic fog, that marks the boundary of what light can show us. This glow is called the cosmic microwave background, or CMB, foreground, and it is the oldest light we will ever see. Roughly 13.8 billion years ago, the universe began in a hot, dense state, so hot that atoms couldn't form. Protons and electrons existed, but the intense energy kept them apart. Like a storm too loud to hear a whisper, light couldn't travel freely. It was constantly scattered by charged particles, bouncing and rebounding in every direction. For closure, the universe then was not transparent, it was opaque, like a cloud lit from within. No telescope could have pierced it, even if one had existed. The light was trapped, unable to roam. Expanded, it cooled, and about 380,000 years after the Big Bang, it reached a temperature low enough for atoms to form. Electrons and protons combined to make hydrogen, and suddenly, light was free. That first moment of transparency released photons in every direction, and those photons have been travelling ever since, stretched into microwaves by the expansion of space. Today, they form a faint background glow that fills the entire sky, not with patterns or stars, but with a gentle, nearly uniform warmth, about 2.7 degrees above absolute zero. You can't see this light with your eyes, but special instruments, like those aboard the COBE, WMAP and Planck satellites, have captured it in exquisite detail. A sky filled not with constellations, but with temperature fluctuations, tiny variations, mere millionths of a degree, that hint at the seeds of galaxies, the earliest wrinkles in space. The CMB is often called the baby picture of the universe, but it's more than a photograph. It's a wall, a limit, from before that moment can reach us. The universe before recombination was, quite literally, hidden, not by darkness, but by brightness too intense, too scattered, too bound. What lies before that wall must be inferred through mathematics, theory, and indirect effects. We can't see past it, not with telescopes. Zimbabwe trying to hear a whisper through a roaring crowd. The noise is too dense, the message too diffused. Some theorists are working on ways to peer deeper, using neutrinos, gravitational waves, or the cosmic background of other particles. But for now, the CMB remains the edge of vision, a final curtain drawn across the very beginning. And that's okay. Speaks. Its ripples and dimples tell a story of
pressure waves and inflation, of density and destiny. It whispers of a time when space was young and hot and still deciding what it would become. So, tonight, as you drift into sleep, imagine the universe wrapped in that soft, glowing fog, not as a limit to curiosity, but as a memory we still cradle, a warmth still touching us from every direction. The light of a time when the universe first became visible. And even now, that light is still arriving, quiet, ancient, patient, like a letter from the beginning, delivered to your eyes. Let's now drift from the largest horizon in the cosmos to one of its most compact. From the glowing wall of the early universe to a place so dark, so dense, that even light cannot escape. The heart of a black hole. Black holes are cosmic paradoxes. On one hand, they're simple, described by just a few numbers, mass, spin, and charge. On the other hand, they're among the most mysterious objects in the universe, because while we can describe what they do, we're still trying to understand what they are. And at the core of their mystery lies a question not unlike the one we've been asking all along. What happens to what we can't see? When something falls into a black hole, whether it's a star, a planet, or a beam of light, it disappears from view. Cross the event horizon, and there's no way back. No signal, no reflection, no final cry. This horizon is not a wall of matter. It's a boundary in space-time, a point of no return. From the outside, it marks the limit of what we can know. And that's where the trouble begins. Because physics doesn't like secrets. According to quantum mechanics, information can't simply vanish. It might be scrambled or hidden, but it must still exist in some form. Yet general relativity, which governs gravity and black holes, seems to allow for information to be utterly lost, gone without a trace. This contradiction has haunted physicists for decades. It's known as the black hole information paradox. Stephen Hawking famously suggested that information falling into a black hole was lost forever, that the radiation emitted as the black hole evaporates contains no trace of what fell in, like burning a book and being left with smoke, but no words. Others disagreed. They proposed alternatives. Perhaps the information is encoded in the event horizon itself, or stored in subtle quantum vibrations, or slowly released in whispers through Hawking radiation. Or perhaps black holes aren't quite what we think they are at all. Some models go even further, suggesting a mirror-like surface called a firewall that might burn information at the edge instead of letting it pass quietly through. But these models raise new questions. They seem to violate the very smoothness of space-time we've come to trust. At the heart of all this is a deeper theme, the tension between knowing and unknowing. Black holes are physical, measurable, describable, and yet they hide things. They stretch our definitions of causality, locality, and memory. And perhaps that's why they continue to fascinate, because they are not just places in space. They are boundaries of comprehension. They show us that even with the most powerful tools, the sharpest equations, the clearest minds, there are places we cannot see into, not because we're not smart enough, but because the rules themselves might not allow it. Schizophrenic, like the cosmic microwave background, black holes still speak. We detect their gravitational waves. We photograph their shadows. We model their mergers. We listen to the ripples they send when they collide, soundless tremors that roll across the fabric of space. So tonight, as you imagine the sky, remember, not everything that matters can be seen. Some truths dwell beyond the horizon. Some pages are folded shut. And that's okay. Because even the dark has its story. And sometimes, the silence holds more than we know. Now, let's take a step sideways, not deeper into the cosmos, but into something stranger, something softly speculative, even playful. What if the limits we see, the edges of observability, the smallest scales, the unreachable distances, aren't just natural? What if they resemble the kinds of boundaries found in something familiar, like a computer simulation? It's an idea that's captured the imagination of both physicists and philosophers. What if the universe is a simulation? This isn't just science fiction anymore. Serious thinkers like Nick Bostrom, David Chalmers, and even some theoretical physicists have considered the possibility. The argument doesn't say we're in a simulation necessarily. It says that if advanced civilizations can create simulations of conscious beings, and if they create many, then statistically, it might be more likely that we're in one than not. But tonight we're not trying to prove or disprove that. We're simply noticing something quietly curious. The universe behaves in some ways like a rendering engine. Work. When your character looks in a direction, the world renders only what's in view. Distant mountains are painted in blurry outlines. Tiny details load only when you approach. You can't see beyond the horizon, not because it doesn't exist, but because the system hasn't drawn it yet. Blinked, consider our universe. We cannot see beyond the cosmic horizon. We cannot probe below the Planck length. We encounter limits, not of imagination, but of resolution. Places where nature seems to say, this far and no further. Particles appear and vanish, probabilistically. Observing a quantum system seems to affect its outcome. Energy states aren't continuous, but come in discrete levels, quantized, like pixels on a screen. Even our observations depend on where we look, how we look, and with what tools. Reality doesn't reveal itself all at once, it offers detail in layers, like graphics loading in a game. Stimulates, there's the question of processing. In physics, there's a maximum speed at which information can travel, the speed of light. Just like in a simulation, where processing speed sets the pace of the experience, the cosmos too has built-in constraints. Bounce these limits coincidental, necessary, or signs of something more? Most physicists treat simulation theory as an entertaining thought experiment. After all, just because something looks digital doesn't mean it is. Nature might simply be granular by its very design. And Occam's razor reminds us, the simplest explanation, quantum physics, relativity, the fabric of space-time, still works beautifully without the need for a cosmic programmer. Blindly doesn't mean the metaphor has no value. Fallback of the universe as a kind of simulation helps us reflect on how we observe and what it means to be inside a system we're trying to understand. It reminds us that limits are not always flaws. Sometimes they're features. Necessary constraints that make complexity possible. And if nothing else, it invites a kind of gentle humility. Because whether we are simulations, stardust, or something stranger still, we're here, asking questions, listening for echoes, staring into the fog and wondering what lies beyond. So tonight, let your thoughts stretch not just across space, but across reality itself. Let them wander to the very idea of being, rendered, observed, experienced. And whether or not we're in a simulation, one truth remains. The mystery feels real, gang feels true. And you are not outside the system. You are inside it, alive and aware. And that is no less beautiful. There's a quiet moment in every journey, when you realise you've gone as far as you can. Not because the road has ended, but because you've reached the limits of your map. Beyond this point there are no paths, only questions. Lineback 2 has such moments, points where the universe offers no more light, no more data, only silence and the possibility that some things may remain unknowable. Yet, science continues. This is one of the most beautiful aspects of the scientific spirit. Not that it answers every question, but that it keeps asking, even when it knows the answer may never come. Consider again the cosmic horizon, the outer boundary of what we can observe. Beyond it, space continues, galaxies exist, stars are born and die, but their light will never reach us, not because it's too faint, but because space itself is expanding too fast. Their signals are stretched into oblivion. Precarious, these places are not imaginary, they are real, and yet for us they are permanently out of reach. Propane. We know this. We understand the equations. We see the light that nearly didn't make it. And still we ask, what's out there? Beginning those first trillionths of a second after the Big Bang, a time when our theories no longer agree, when space was so hot, so curved, so quantum, that the laws of physics, relativity and quantum mechanics, begin to clash. We don't know what came before inflation. or if before even means anything. We can model, simulate, approximate, but the truth remains wrapped in math too abstract to unfold completely. Or the nature of consciousness, hovering gently between physics and philosophy. How does matter become aware? What is it that experiences the night sky when you look up? These are not failures. They are boundaries of understanding, not because science has stopped, but because reality, at some level, resists resolution, like a painting too large to view in full, or a melody whose final note always fades before we reach it. And this is where humility enters. Proud, it is not certain, it does not claim a throne of answers. Instead, it bows to data, to nature, to the unknown. It says, this is what we know, this is what we do not, and here is what we are trying to learn. Demolished, it's a posture not of defeat, but of grace. The limits of knowledge is not to stop wondering. It's to respect the mystery, to sit at the edge of the horizon and listen, not for answers, but for the silence itself, submerged, and sometimes that silence speaks, in the patterns of galaxies, in the symmetry of particles, in the harmony of a universe that, despite its unknowable corners, allows us to ask, to think, to reach. Tonight, let your thoughts rest, not in certainty, but in openness. Not in what we've solved, but in what still dances just beyond view. There is wonder in not knowing. There is peace in not needing to finish the puzzle. And perhaps, in those blank spaces on the cosmic map, where no equations can yet go, is the room where awe still lives. In all our talk of galaxies and light years, of expansion and event horizons, it's easy to forget something simple, something quietly profound. You are here, glazed out there among the drifting galaxies, or beyond the cosmic veil, or behind the black hole's horizon. You are here, sitting somewhere quiet, maybe at the end of a long day, letting these words drift across your thoughts like soft wind over still water. And still, the universe flows through you. Every atom in your body was forged in a star. Every breath you take follows the rhythm of cosmic laws. Even your sense of time, how this moment passes gently into the next, is bound to the ticking fabric of space-time itself. Inside the universe, watching it happen, you are an observer within it, and that matters. In physics, the observer plays a strange and essential role. In quantum mechanics, particles exist in clouds of possibility until they are measured. In relativity, motion and time depend on your frame of reference. There is no view from nowhere, only views from somewhere, and you are always somewhere. But more than that, you are aware. You wonder. You listen for things that have no sound. You hold questions not because you must answer them, but because you feel them. In that way, the edge of the universe isn't just a matter of physics, it's also a matter of presence, art of the cosmos, and the cosmos is part of you, not just through atoms and light, but through attention. You give meaning to what you see. You assign wonder to what lies beyond. You are the meeting point between knowledge and mystery. Ot small. When you look at the stars, they do not know they are stars, but you do. When a photon travels for billions of years to reach your eye, it is your gaze that completes the journey. You, the observer, are not a passive witness. You are part of the story, ambiguous, and you don't need to know everything to belong in it. Blackmail ye, that's the softest truth of all, that even in the face of the unknown, even in the dark where no telescope can reach, you still matter. Your awareness is not reduced by the vastness around you, it is framed by it, elevated by it, made meaningful because there is so much still to learn. So tonight, as the stars continue their quiet song above you, let yourself rest in that stillness. You don't need all the answers. You don't need to reach the edge. You are already touching it, with your thoughts, with your curiosity, with the simple, enduring fact of being here, now. Listening. There's a moment, just before sleep, when your thoughts begin to float, not away from meaning, but towards something softer, a feeling, a hush, a kind of reverence. That feeling has a name, kriyat, awe. Position it often visits in cathedrals or on mountaintops. Awe lives just as easily in numbers, equations, and galaxies. It lives in science, not despite its precision, but because of it. For many, science feels like the opposite of wonder, like turning on a light that ruins the mystery, as if knowing how something works steals its magic.
But the truth is gentler and deeper. To understand the stars is not to make them ordinary. It is to find that they are more wondrous than we ever imagined. The universe is not smaller when we know more of it. It's larger, stranger, more elegant. We've learned that starlight is ancient, that space can bend, that time is part of the structure of reality, that particles can be entangled across vast distances, that entire galaxies are moving away, carried on a tide we cannot feel. These aren't just facts, they are doorways to awe. And awe, in the realm of science, is not a weakness. It's not sentimentality. It's fuel. Einstein, Sagan, Feynman spoke openly about wonder. They didn't hide from it. They didn't apologize for it. They let it guide them, not as a conclusion, but as a companion. Because awe reminds us that knowledge is not a tower. It's a window. Flooring. When you feel awe, something shifts. You stop trying to measure yourself against the universe and start seeing yourself as part of it. Small, yes, but also connected. Brief, yes, but also aware. And that's a miracle. Prejudice, to be a bundle of atoms arranged just so, capable of thought, of joy, of curiosity, to exist at all and to know that you exist, feels at times like too much. And so we sit in silence, not because we have nothing to say, but because the words are too few. Alphabetical, the nihilance, that pause, is awe. It isn't loud, it doesn't ask for applause. It sits beside you, gently, like an old friend watching the same night sky. Science, in its clearest form, honours that feeling. It doesn't just count stars, it listens to them. It doesn't just label galaxies, it follows their motion like music. It tells us, this world, this universe, is not ordinary. It is unbelievably rare. Not because it is made of stardust and energy, but because you are here to notice it. As you breathe softly in the dark, let that awareness fill you. You don't need to solve anything. You don't need to be certain. Just let the awe arrive, like a tide. Let it carry you. Let it whisper, photographic. You are part of something vast. Is beautiful.
We spent so much time talking about the edge of the universe, where space might end or time might fold, or light can no longer reach. But maybe, quietly, we've been circling a different kind of edge all along. Not the edge of the cosmos, but the edge of perception. What we call the edge may not be a place at all. It might be a metaphor, a way our minds describe a feeling we've known since childhood, that something is just out of reach, that there's more, that no matter how far we look, a little more mystery always waits just beyond. In the physical world, our senses are bounded. Your eyes don't see ultraviolet. Your ears don't catch the high-pitched cries of bats. Your hands feel texture, but not atomic structure. You live within a shell of sensory limits, like a small bubble drifting through a much larger ocean. Its have edges. There are ideas you can hold clearly, others that shimmer, then vanish. You may try to picture curved space, or timelessness, or infinity, but these concepts resist full capture. They brush against you, then dissolve. And maybe that's the point. We call outside the universe might actually be the outer edge of experience, a line not drawn in the sky, but drawn inside, where comprehension fades into intuition. Monitored as the eye cannot see its own lens, we cannot always see the framework through which we observe the world. Our questions, what lies beyond, where is the edge, are shaped by that framework, by how we're built, by what we've learned to expect from space and time and form. The universe owes us no explanation in our native tongue. It does not think in metaphors. It does not simplify itself for comfort. It just is, and our minds reach toward it, not to grasp fully, but to touch, gently. The idea of the edge endures. It is not merely a scientific question. It is a symbol of curiosity, of boundary, of the place where the known gives way to the unknowable. You feel it in quiet moments, standing at the edge of a forest, watching the sea disappear into mist, hearing a sound you can't place, sensing a thought you almost remember. These are small versions of the same question. What lies just beyond this? And the answer is always the same. Step closer. Step closer. Pause. Because sometimes, standing at the edge is enough. Don't have to cross it. You don't have to explain it. You can just be there, letting your awareness lean gently forward, like a candle tilting toward the dark. That's what metaphors are for. They give shape to the formless. They make the unseeable feel like something you can cradle in your hands, even for a moment. Think of the edge not as an answer to find, but as a place to visit, a soft boundary, a curve in the mind, a quiet shoreline where thought becomes wonder, and on that shore you can sit, you can breathe, you can listen, not for the edge to speak, but for yourself, noticing it. Let's rest here for a moment, between seconds, between places, between who you were a moment ago and who you'll be tomorrow. Time, space, and self. They seem so obvious, don't they? Time is the ticking clock, space is the room we stand in, and the self is the quiet awareness behind your eyes. But when we look closely, softly, we begin to see something strange. These are not fixed things, woven illusions. Start with time, confines it like a river, flowing forward, carrying your memories downstream. But in physics, time doesn't flow. It's a dimension, like space. It doesn't move. We move through it, or perhaps we're stretched along it. Einstein showed us that time is relative. A moment for you might be different for someone else, depending on how fast you're moving or how deep you sit in a gravitational field. There is no universal now. The present is a perspective. And space? Este, too, isn't as simple as it seems. It bends, it stretches, it reacts to mass and energy. What we thought of as a passive backdrop turns out to be dynamic, alive with curvature and tension. Space and time aren't two things. They are one. Space-time. And the self? That might be the strangest illusion of all. You feel like a fixed point, a steady you moving through time. But every 7 years, nearly every atom in your body is replaced. Your thoughts change, your moods shift. Even your memories are not recordings, they are reconstructions. Who then is the you watching the stars tonight? Prestige the self is like a wave, a pattern, not a thing. A rhythm of thoughts, memories and sensations, bound loosely together by continuity and attention. You are not a static shape, you are a process, a flowing. A moment of awareness, stretching across space-time like a ripple. That makes you less real, it makes you more dynamic. The poet Rilke once wrote, "I live my life in widening circles." And perhaps that's what we all are. Not dots, but spirals. Not nouns, but verbs. Not things in time, but moments of time, folded gently into thought. So when we speak of the edge of the universe, or the beginning of time, or the shape of space, we are also speaking, quietly, about ourselves. Not as separate observers, but as beings within the fabric we're trying to understand. That way, the edge of the universe is also the edge of the self. It's where our stories begin and blur. It's where our need to understand meets the vastness that cannot be held. It's where we stop being certain and start being still. So tonight, let go of the idea that you are a fixed point. Instead, picture yourself as a thread, woven through time, stretched across space, shimmering with questions. You don't need to pin yourself down. You don't need to be solid. You can be a ripple, a breath, a gentle thought drifting across a quiet universe. And maybe, just maybe, the universe feels you back. Long before telescopes, before satellites and space probes, before equations curved space and stretched time, there were stories, not of expansion or entropy, but of eggs, trees, turtles and dragons. Reclaimed were the first cosmologies, not written in star catalogues or mathematics, but in song, in carving, in the hush of firelight. And though they lacked the precision of modern science, they shimmered with something we still carry, a longing to explain where we are, what surrounds us, and what lies beyond. Take the Norse world tree, Yggdrasil, with its roots in the underworld and its branches holding the heavens, or the ancient Hindu concept of Brahmanda, a cosmic egg containing the entire universe. The Chinese spoke of Pangu, the giant whose body became the world. The Egyptians believed the sun god Ra sailed across the sky in a celestial boat each day, battling darkness each night. In each case, these stories didn't merely describe space. They gave shape to meaning. The edge of the world wasn't just a location, it was the place where order met chaos, where gods slept, where monsters waited, where the known gave way to the unknowable. And here's something quietly beautiful. Even these ancient tales imagined an edge. The Babylonians saw a dome over a flat earth. The Greeks imagined concentric spheres of crystal, holding the stars like ornaments. Polynesian navigators pictured layers of sky and sea,
with the horizon as a threshold between realms. In every corner of the world, people looked up and outward, and filled the silence with story. The loon's myths weren't wrong in the way we sometimes assume. They were models, ways of organizing experience. Early sketches on the same canvas modern science continues to paint. They used metaphor and symbol where we now use data and theory. But both are driven by the same force, curiosity. Flames, even now. Our best cosmological models are not final answers. They are stories written in a new language, mathematics, observation, simulation. We speak of inflation, dark energy, the curvature of space, the birth of time. But underneath, the heart of the question is the same one people whispered beside ancient fires. Where are we? Assess this place. And perhaps when we picture quantum fluctuations or multiverses or bubble collisions in higher dimensions, we're not so far from the myths after all. More accurate, more predictive, more grounded in evidence. But they are still, in a way, cosmic storytelling. Our minds reaching outward, shaping mystery into meaning. So tonight, if your thoughts drift towards celestial eggs or star-bearing trees, or great ships sailing the sky, let them. They are not childish. They are ancestral echoes of a question that never left us. Yourself not just as a modern thinker with the internet in your pocket, but as a storyteller in a long line of wanderers. Looking up, imagining what holds the stars in place, dreaming what lies beyond the horizon. The edge of the universe may not be a wall, but the human imagination will always find a way to frame it. Some questions don't have answers, not because we haven't found them yet, but because they may never arrive. And strangely, that's what makes them useful. We often think of questions as doors, each one waiting to be opened with the right key. But some questions are not doors, they are windows, placed in the wall not to be passed through, but to let in light, to remind us there's something vast on the other side. What came before the Big Bang? What lies outside the universe? Is space infinite? Is time a loop? Windshield, there's something rather than nothing. These aren't idle speculations, they're real, meaningful, foundational. But every time we lean toward them, they lean a little farther back, like the horizon. Always visible, always retreating. Still, we ask. Because even when a question resists being solved, it shapes the way we think. It sets direction, it organizes curiosity. It becomes a star to steer by. Fuel not just science, but art, philosophy, music, and story. They give rise to theories, languages, symphonies. They don't lead to conclusions, they lead to depth. Think of a child asking, "Why is the sky blue?" At first, the answer is simple, scattering of light, but then come more questions. Why does light scatter? Why does the atmosphere do that? Why do we see light at all? And suddenly, you're tumbling down a well of discovery that ends not in colour, but in the quantum structure of photons, in the biology of the eye, in the psychology of perception. All from one question. Discharge now imagine asking, what exists beyond the edge of the universe? Even if the answer is, the question may not apply. The asking still moves us. It reveals how we think. It teaches humility. It opens our minds to the possibility that some concepts, like outside, before, or beyond, are tools we've inherited, not truths we've discovered. And that's no small thing. Positioned in a world hungry for answers, questions like these offer something gentler, a chance to pause. To dwell not in solutions, but in presence. To wonder without needing to resolve. Understand this. Many of the great discoveries began with something unanswerable. Newton didn't solve gravity, he noticed the question. Einstein didn't begin with a finished equation. He asked what light would look like if you chased it. In every case, the breakthrough wasn't the answer, it was the quality of the question. Brushing so tonight. If your mind drifts toward one of those soft, unsolvable mysteries, don't push it away. Let it sit beside you, like an old friend who doesn't speak much, but whose company calms you. Let your thoughts stretch not to finish something, but to feel it. Let the question open a space in you, a quiet chamber where not knowing becomes not a lack, but a kind of peace. Not every question needs an answer. Fallback just need to be held. There's a strange kind of peace that arrives when you finally stop reaching for answers. Not because you've given up, but because you've realized you don't need to hold everything.
You can set it down. All of it. The questions, the calculations, the metaphors, and just breathe. For most of your life, you've been taught that knowing is power. That to understand is to control. That to not know is to be unprepared, uncertain, even afraid. But the universe does not ask to be solved. It asks to be witnessed. And sometimes witnessing means letting go. Letting go of needing the edge to be a place. Letting go of needing time to be a line. Letting go of needing answers to arrive wrapped and labelled ready for storage. There is a deeper comfort that comes not from knowing what lies beyond, but from accepting that we may never know, and still being okay with that. Still being whole. You see, the universe is not a riddle. It is not a trap. It is not testing you. It simply is. And your presence within it does not depend on your mastery of it. You belong, whether you understand or not. This is what stillness teaches. In the quiet, you begin to feel that the urge to know, the beautiful, relentless ache of curiosity, doesn't always need a destination. It can just be. A motion without an endpoint. A candle that lights but never burns out. Milieu's becomes not a gap but a landscape. One you can live inside without needing to fill every corner. And perhaps that's where peace lives. Not on the far side of an equation, but just past the point where certainty gives way to trust. A trust that the stars will still shine, even if we can't name their every flicker. That gravity will still hold, even if we don't know why it bends just so. That the edge, if there is one, can be felt, not seen. Tonight, let yourself rest in that place. Flooring without borders. A space where you don't have to figure it all out. Where not knowing is not a failure but a kind of grace. Like standing by the ocean and not needing to count the waves. Like watching the wind move through leaves and not needing to chart its path. Weath the stars and letting them be what they are. Distant, quiet, unknowable, and beautiful. You don't have to chase them. You can just look. And in that looking, find something softer than knowledge. Fiberglass than explanation. A piece made not from facts, but from letting go. There's one final tool we haven't talked much about. Not a telescope or a formula or a satellite, but something quieter, older, always close at hand. Imagination. Childish sense, not in the sense of make-believe or escape, but in its truest form. The ability to reach gently toward what cannot be touched, to see with the heart what the eye cannot resolve, to think, not to conquer, but to explore softly. Imagination is a kind of telescope, not one that reveals hard edges, but one that opens soft horizons. It doesn't sharpen, it suggests, it doesn't measure, it invites. And when the universe becomes too large to grasp or too quiet to hear, imagination steps in, not to replace knowledge, but to extend it, to give us metaphors, to build bridges between thought and feeling. You've already used it many times tonight. When we spoke of the edge of the universe, you pictured a line, maybe a glow, maybe a veil. When we said light takes time to travel, you imagined starlight as a letter sent across eons. When we spoke of yourself as a ripple in space-time, your mind drew the shape, soft and slow, just enough to hold the idea. That's imagination at work. Trolley, not escaping truth, meeting it halfway. Even the greatest scientific leaps begin here. Einstein visualized riding alongside a beam of light. Feynman saw particles dancing like paths in space. The double helix of DNA came, in part, from dreams and sketches and gut feelings. Imagination isn't what science grows through, because even when we cannot prove something like what lies beyond the universe, or before time, or inside the smallest scales, we can still feel around it. We can ask, gently, what might it be like? What would it feel like to live in such a reality? And sometimes, the feeling leads us closer than logic alone could go. Flooring. This doesn't mean we abandon rigor. It means we allow room for wonder to breathe alongside it. That we honour both the microscope and the moonbeam. That we let truth and beauty sit at the same table, even if they speak different languages. So tonight, think gently. Our thoughts loosen their grip. Let them wander, not to solve, but to touch. Let the edge of the universe become not a problem, but a poem, a lullaby, a quiet reminder that some distances are best felt, not measured. And let imagination be your soft telescope, the one that doesn't need lenses, just presence, and stillness, and trust. Punished. Even if we never know what's out there, we can still reach toward it with the light of our minds and the hush of our hearts. And now, as we come to the quiet end of our journey, let's take a soft breath together. Not to retrace everything with sharp lines and tidy labels, but to drift backward gently, like starlight arriving after a long journey. We began with the visible, the light, the galaxies glowing like lanterns in the dark. We spoke of what we can see, the stars that tell us stories in their silence, the expanding fabric of space carrying them slowly beyond our view. We touched the horizon, not the one drawn on maps, but the one drawn by time, the edge of what light has had time to reach, the place where visibility fades not into darkness, but into deep time. Even expansion has no outer wall, that space grows within itself, that the edge is not a place but a limit, curved, shifting, impossible to stand on. Then we stepped closer, into ideas, into metaphors, into mirrors. We saw how the universe doesn't have an outside, that asking what's beyond is like asking what's north of the North Pole. We marvelled at how language itself bends and falters near the edge of the cosmos, and all along the way we found reflections, not just of galaxies, but of ourselves. Because to talk about the edge of the universe is also to talk about being human. What cannot be known, to chase what cannot be caught, to hold what cannot be named. Crimson, we hold it, softly. We looked into the ancient fog of the cosmic microwave background, the first light that ever travelled freely, and found a quiet wall. We listened to the silence of black holes, places that hold their secrets beyond even the reach of light. We imagined possibilities, simulations, patterns too fine for us to resolve. And we stepped into humility, the space where not knowing becomes its own kind of understanding. And finally, we let the mind go, pristined on myth and awe and metaphor, mystery to be beautiful, even when unsolved. And you, yes you, have been part of this journey, a gentle witness, a thinker resting beside the unthinkable, a soul wrapped in stardust, listening for echoes not just of the cosmos, but of meaning. So here, in this moment, let everything soften. No more need for diagrams or distance, no more need for what's next. Just a stillness, a memory of where we've wandered, blackmail map drawn in feeling, and a deep, deep peace that you were here for it all. There's a quiet image that stays with you, long after the facts have faded. It's the image of standing, metaphorically, at the edge of everything. Not the edge of a cliff, or a road, but the edge of knowing. The edge of all you can see, feel, or understand. And here, right now, we're standing there, together. But what we've found isn't a wall, not a sharp barrier, not a cold silence. JFK into something softer, a resting place. Balloons don't always mark endings. Sometimes they mark transitions, like the hush before sleep, like the silence after a deep breath, like the pause between notes in a lullaby. Universe, for all its stretching and expansion, offers us a kind of rhythm, a heartbeat of movement and stillness, kindergarten and surrender, unmistaken calm, and the edge, this imagined edge we've wandered toward tonight, isn't telling us to go farther. It's inviting us to rest, to let the stars drift out of focus, fiberglass to let the questions grow quiet, blackmail the unknown without needing to cross it. You don't have to reach beyond the edge. You don't have to answer what lies outside. You can simply be here, where the map fades and the imagination begins.
where understanding pauses and peace begins to speak, like laying in a field at night, knowing you won't name every star, but loving that they shine anyway. This is not a defeat. This is not a gap in what we've done. This is the most human thing of all, to walk all the way to the end of thought and choose to sit, to breathe, to trust. So tonight, let this place be your edge. Not an edge you fall from, but one you lean against. Not the edge of a question, but the edge of a lullaby. Consciously where the universe is no longer a puzzle, just a presence, and you, resting within it, are not lost. You are held by gravity, by thought, by wonder, buffering, by the gentle stillness that comes only after a long and beautiful journey. Brush doesn't ask you to move, to be, to sleep.